Okay, you ready? This is Chemistry 2, lesson number 2. Lesson number 1, you learned that atoms are tiny. They're small, beyond anything you've thought of as being small. They are so small that there are more atoms in a marble than there are grains of sand on Earth. They're tiny. They're incomprehensibly small. They're so small that light won't even bounce off them to come back to our eyes, so we can never see them. Which is, yes, what?
Um, how many atoms wide is a penny?
Trillions. Hundreds, thousands, hundreds of thousands, millions, then billions, which is 1,000 million, then trillions, beyond that. Okay? It's once you start saying to a kid 1,000,000, that number starts to almost become meaningless. So, they're more. Did you ask how wide a penny is?
Yeah.
Okay, yeah. That penny, there's more atoms across a penny than there are grains of sand across Earth, probably. Probably about the same, or I could be off, but that's talking about it. Now, so atoms are small, and the other thing, which I probably didn't go into enough, is atoms are mostly empty space. Atoms are not solid. The ancient Greeks, I forget who thought of atoms as tiny, indestructible little BBs or marbles or ball bearings, and that everything was made of them. That's pretty good 2,000 years ago, 23,000 years ago. But atoms, and I found my boards, these boards should pass through each other. They're 99.999% empty space. They're made of atoms. Carbon, hydrogen, oxygen, nitrogen, maybe some nitrogen proteins. But there's no... They should go through each other. Now, why don't they? Okay? Is that a good question you were going to ask? Okay, these boards should pass through each other. Atoms are mostly empty space. And we kind of use this to draw an atom, so I'm going to need, somebody come here and hold this board up with me. Somebody hold that up on the side. Okay, hold it up. Hold that still so I can draw like a chalkboard. I hate my chalkboard isn't here. All right? Good job. Yeah, we draw an atom incorrectly because it's so big. I can't make an atom here, the nucleus of an atom, and then have the electron far off campus in the next building. So I scrunch it up a whole bunch and just say there's an electron whizzing around it. Okay? Now the reason atoms like these boards seem so solid is because the electrons are moving so fast around the atom that for all practical purposes, they're everywhere at once. Now think about this. An atom is tiny. An electron's going about, I don't know if anybody knows for sure, but I've heard like 1,000, 2,000 miles an hour. Or miles a second. I forget which. It's fast. Miles a second. Around the nucleus. If you think how small an atom is, an electron is making billions and billions and billions of trips around this nucleus. So for all practical purposes, it'd be like trying to put your finger in the fastest fan. It's going to hit you. So these atoms, even though they're almost all empty space, they occupy a lot of space, and those electrons are hitting each other. So even though the atoms in the wall, the atoms in your head, the atoms in your hand, the idea that most of this part is moving around is pretty mind-boggling. I don't want to say insane, I'll say mind-boggling. So that's where these electrons are moving. And the other atoms, and when those electrons stop and form pairs and sort of form bonds, that's what they are. That's when you start to get solid matter. Uh-oh. What did you break, Zaylin? Sear?
I didn't break anything.
All right. Now, that is your atom. Okay? I'm going to tip this down so you can see that better. Now, that's a representation of an atom. They had that, the Bohr model, like they've had that for about 100 years almost. And it's not exactly right. Atoms actually, let me see if I can find, they think atoms are really shaped with the electrons whizzing around them, something like this. And these are different atoms, obviously, with different shapes. Here, put your finger by some and see them. So you can sort of see, yeah, you can sort of see their shapes. And it said atoms are incredibly tiny, and they're way more complex than people realize. But for our practical purposes, we can sort of draw an atom to help us understand what's going on, like this. Yeah.
Do they circle like so? If that's here, wait.
You want to know if they go clockwise or counterclockwise?
No, wait. Kind of, but.
I told him to ask questions.
If this is the nucleus.
Come here.
Then,
Throw it here.
And I'm gonna squish it down. Does it go like this, or does it go?
Good question. Come here. He asked this. He said, if this is the nucleus of an atom, does the electron go like this? Or does it go like this, and this, and this, and this? It goes like this, and this, and this.
Okay.
We're not quite sure exactly. And the shapes change.
Does it have a
as
pattern that it goes in?
Not, yes and no. It doesn't have a specific pattern. It just sort of has probabilities. And then it gets to, then we're talking about crazy things like quantum mechanics. And that's a great question. That's a phenomenal question for a 12-year-old now. Because they don't go in an exact pattern.
I'm 13.
Oh, that's true. You turned 13 last month, 2 months ago. Yeah. So anyway, that gives you an idea of the pattern of things. So these electrons are going, and think, remember, they're going around 1, 2, they're going around, wait, 1 second, 1 second. That's already done 1 billion trips around this nucleus. And as he said, it's all squished down. So the atoms are pretty complicated. And they're rather, actually, we're trying to look at some of the simplified versions of it. But that's your electron going around an atom. Now, an atom has 3 parts. And this is pretty neat to figure it out. Hold this up. And this is something you should all put in your notes. Hold that for me. An atom has, we do know this. We know the center of an atom is incredibly dense. It has parts. It has neutrons. And then there are protons. And then it has electrons. Right, and backwards is kind of tough.
Neutrons,
Protons and electrons. Yep. It has those. And this is kind of neat. The electrons are the ones, the tiny parts that are spinning around the outside. They're about 1/2000th the weight. They're about 2,000 times smaller than the protons and the neutrons. The neutrons are slightly, tiny bit heavier than a proton, but not enough to really count. And this is really about 1800, like 1836 or something. But yeah, they're small. So some teachers will say, oh, the electrons have no mass. That kind of confuses kids. They actually do have some mass. But it's so much we can ignore it. It's like saying, well, what's the car weigh?
So little we can ignore.
Did I say too much?
Yeah,
so little. The electrons weigh so little we can ignore it. It's like saying, how much does that car weigh? How much does that car weigh? Oh, how much does that car weigh when it's dirty? Okay, I guess if you wash the dirt off the car, it would weigh a little less, but it's not enough to worry about, you know? So we say the electrons don't weigh anything, even though they do weigh a little bit, but to simplify our calculations, and they have a charge. I spelled charge terrible, or scrunched up, and mass. So a neutron and a proton, you could take, it doesn't make any sense to use pounds or kilograms because it'd be, 1 times 10 to the 20, it'd be huge numbers. So we just call the mass of one proton 1. And now the neutron really would weigh 1.000, but or 1. That's really not worth considering. Give me a minute. So we'll just call that 1 to be simple for us. So the neutron has a mass of 1, proton has a mass of 1, and this unlikely little, and the electron would really be like 0.001, but we'll just call that 0 because it's so much. You could have 1,000 protons and it still wouldn't, or I'm sorry, you could have 1,000 electrons and it still wouldn't be the weight of 1 proton. So we'll just call that 0. Now, these are 2 traits. Their mass, how heavy they are, how much matter is in them, and charge. Well, the neutron is neutral.
What does the 1 stand for? 1 pound, 1 cent, 1.
What did I just say? I said the mass stands for, it'd be like 0.0000001 pound. It'd be like 0.0000001 ounces. And that's just too small. You know how you say a dozen eggs when you mean 12?
Yeah.
So we're going to say the mass is 1. And they call that 1 atomic mass unit.
Okay, atomic
mass unit. Okay, the charge of a proton is plus 1, which would be like 0.000 volts. Volts are too small. And the electron is negative. So electron and neutrons, you need about the same number, or you're going to have a charged atom. And you call a charged atom an atom.
All protons are positive, right?
Yes. You call a charged atom an ion.
How much electrons would you need to like power a remote control car or something?
Okay. Well, you would need billions and billions flowing through a wire. Billions and billions and billions. That's why we're talking about an atom. Now remember how small an atom is. So we're talking how small an atom is. We're talking tiny, tiny fractions of what we would think of as electricity, and tiny, tiny, tiny fractions of what we would think of as pounds or kilograms or something, or ounces. All right? But when we're talking about chemistry, we use this instead of having awkward numbers. So we have these atoms, or these particles that make up atoms. The neutron, proton, and electron. And if you want to go farther into physics, let me get that shade off of there. You go farther into physics, you're going to have something like, you're going to understand that a neutron is made of 2 down quarks and an up quark, and a proton is off quarks. Electrons, we don't seem to find anything smaller than an electron yet. So this is chemistry lesson number 2. There's 3 parts of an atom. Neutrons, protons, and electrons. Hold this yourself. Where's my, okay, there it is there. I'll make different colors just for our thing here. The protons and neutrons are in the center. The little protons I'll draw black, and the little neutrons I'll draw red. The neutrons here, and they seem to be in the center, and then whizzing around the outside of them, far, far away, not miles on an atom, but just huge distance-wise, are the electrons, and they're much smaller, and they're whizzing around, they're taking a billion trips around this atom a second, actually more than that, but it doesn't matter there, and they're all kind of weird shapes, and these are charged negative, these are negative charges. These little protons have positive charges, so if I have 2 protons, I should have 2 electrons, or the atom's going to have a charge. And the neutrons, they don't really change the atom much. They're the least important part of the atom. So that is kind of what an atom is made out of. All right? And there's only, think about this. This is pretty cool now. This gets to where we can start working with something. There's only 100 atoms, and they're all only made of 3 things: protons, neutrons, and electrons. So that's this, Chem lesson 2. Hope it helps somebody.